Good afternoon. Welcome to the Embedded Executive Podcast. My name is Rich Nass, and I am with Open Systems Media, more specifically with Embedded Computing Design. This week, my guest in the podcast is Amir Panoush. He is the CEO of CEVA. How you doing, Amir?
Very good. Good afternoon, Rich. How are you doing?
I'm doing
Pleasure to
great.
be here.
Thank you. So big week for you guys. You just turned out your 20 billionth device. Is that correct? Did I get that right?
Yeah, pretty much. It's a huge milestone for us, and we are very happy with that. Really enabling 20 billion devices through the last 2 decades. And even more importantly, just this year, we enable about 2 billion devices on an annual basis, which really, if you think about it, it's quite amazing. It's like 60 devices every second that we enable across the smart edge market. And we are very fortunate to have so many customers, hundreds of customers using our technology. And we look forward to what that means for the next chapter for us and with our customers. Super
What did
exciting.
you really put that in perspective? You said 60 devices a second?
Yes, pretty much. Yeah,
That's
amazing.
crazy. Okay.
Yeah.
Is it safe to assume that's mostly handsets because that's the super high volume?
No, actually, not at all. Definitely, we have significant market share within the handset market, but we've expanded very broadly in the last decade or so. I would call it across the whole IoT or the smart edge markets, which really includes handset, as you mentioned, all the consumer IoT, the wearables, the hearables, the TWS devices around the smart cameras, smart home devices, the industrial IoT for smart meter tracking devices and logistics devices and so on, and even wireless infrastructure, automotive, almost every device that you can think about it moving around us and helping us to get things done or to be aware. We are most likely with some kind of a CEVA technology inside those devices.
So to make sure we're speaking the same language, what is smart edge to you?
So, so first, the smart edge from a market segments, in our case, includes mobile, PC, automotive, wireless infrastructure, consumer IoT, and industrial IoT.
Well, that's
But
everything.
with the exception of the cloud hyperscaler, so we are not really so-called addressing the cloud infrastructure side or the hyperscalers, but pretty much everything else. You're right on that.
Okay, but it's the word smart that I want to focus on here because what you defined was the edge, but you're saying smart edge. Is that different from the edge?
Yeah. So if we take let's say we go 2 decades ago, and 2 decades ago, it all started with basically from the PC moving to mobile, and our devices started to become portable. But we have pretty much few devices so-called connected to the internet with IP address. Then came the IoT revolution, so-called the last decades, where those devices become connected. So they will do some compute, some processing, and they all became connected. And now we have hundreds, if not thousands, of IP around us with all those devices connected. And as we move forward to this coming decades and beyond, what we believe we are going to see is that the AI that is really is revolutionize how things are done and will be done in the future. And most of that today is running on the cloud to do both to do the training and the inference, is moving right now to the edge devices, so-called to the client devices that are around us. And this is for us the smart edge. Basically, devices that have done compute with connectivity now are going to do all the inference, all the neural networks execution embedded inside those devices.
So you sort of danced around artificial intelligence with a lot of these other things that you're talking about, but this is getting extremely complex. Now, the things that you're referring to, we're bringing more and more devices in. It becomes more complex, both from a system design perspective as well as the all-important security perspective. So where does CEVA fit in both of those camps? Making it not making it less complex, but making it something that it is that a designer can actually design and then also to make sure everything stays secure.
Yeah, so where we come in place is that if I'm an engineer and I want to go and build those systems, right? We are really there to help them with the simplicity of the design. So things are ready and ready to go. And with that, the time to market and the solution is extremely power and capable efficient for the device that they want. So let's say I'm an engineer, I want to build that system. In the past, I took some kind of a CPU, the central compute functionality from ARM or RISC-V or type of capabilities. Then I need to add connectivity around it. That's where CEVA come to play, whether it's a Bluetooth, Wi-Fi, UWB, cellular IoT technology. All that engineer can get so-called plug-and-play solution that knows it's going to work, it's mature, have tested in the field in billions of devices, and ready to go with the latest and greatest standard of that technology. But then the latest that comes from us, and this is related to AI and the inference capabilities, now all those systems needs to run neural networks on the edge. What's super important for those devices is that it will be extremely power efficient, size efficient, and with that, of course, cost efficient to get to that special form factor or that special device. What we at CEVA provide to all those engineers is the ability to get plug and play NPU, neural processing unit technology, that is dedicated, customized to that market segment or that use case that they need, and basically be able to run quite independently of the CPU or the GPU functionality in order to enable the complete system.
Where does the responsibility for the algorithms reside in this architecture that you're just defining? Is it CEVA's responsibility? Is it your customer's responsibility? Or is it the end designer's responsibility? Or is it all of the above?
So we don't build so-called models, the neural networks model, but we are completely responsible in supporting the engineers on how to run those models very efficiently on the device, so-called inside the device. So our NPU technology is completely, has the comprehensive capabilities, both from the compute, the scheduling, all the optimization like sparsity and many other things, and the access to the memory, so-called cache, L1, L2 cache, to do all the neural networks layers inside the device completely independently. And we provide both the silicon IP, so-called, and the software IP, this complete software SDK with compilers and everything to be able to do the offline and the runtime of that compute subsystem. In addition, with our very strong inherent engine DSP, we provide a complementary DSP to do all the pre-post processing of any kind of multimodal sensors inputs that are coming, whether it's vision sensors, motion sensors, audio sensors, all those things from the analog to digital domain that are coming to make the device contextual aware. For that, we have the pre-post processing of the DSP, plus the NPU that runs the actual neural networks model.
Do you encourage the community to make use of open source?
Definitely, we're also supporting open source, both from the model perspective. There are great open source models there, as well as compiler open source tools and other things. We work with the ecosystem, and I think it's important to be able to support this type of open source capabilities, whether it's the software stack or the models themselves, to enable overall the propagations of all the solutions in the ecosystem, and to support well the different engineers in different groups that are relying on significant portion of open source.
Okay. If we were having this conversation 24 months from now, what's the announcement we'd be talking about? And I know it would be 50 billion or 100 billion units, but let's talk more about the application space. What's coming that people aren't aware of?
I think what is really coming, and I think people underestimate, is how much the AI capabilities or the ability to make our devices much more capable is really moving from the cloud to the edge. And by that, what I mean is if we will wear AR glasses or if we will use our TWS or other devices, you will be able to do language translation, different type of imaging rendering, contextual awareness that is much more advanced with noise cancellation, many other things, all done locally in the embedded devices. And that will propel so many new use cases that honestly, many of us cannot foresee right now. But that propagation is really happening. Like what happens with the connected IoT, with all the devices around us fully connected, they will really all become fully so-called capable with AI and smartness. And for us, this is the revolution that we believe we were going to support very well and see as the next 2, 3 years and way beyond that.
That is awesome. And I look forward to it. And put on your calendar 2 years from now, we'll have that discussion.
Absolutely, Rich. Looking forward to that.
Thank you for joining me. That was Amir Panush. He is the CEO of CEVA, and I am Rich Nass with Open Systems Media.